in here. I think I have a 9-question Schoology test we'll do on Friday before our real life thing. So you ask when the next test is. There you go. Cool? So that should be helpful for you. All right. So worksheet 5.6 is what we did, I believe. Cancel. All right, so the first one says a candy box is made out of a piece of cardboard that measures 8 inches by 12 inches. Squares of equal size will be cut out of each corner. The corners folded up to make a rectangular box with no top. What size squares would need to be cut from each corner to optimize the volume of the square or the cube or the box? All right. So we have 8 by 12. Agree? Cut the corners out. We don't know how big the corner is going to be, so they're each x by x. So in order to find the volume of this, that means that this portion here is no longer 12. It's 12 minus 2x. And this edge right here is no longer 8. It's now going to be 8 minus 2x. In order to find the volume of it, you're just going to go x times 12 minus 2x and 8 minus 2x. And then what you should do is you're going to graph it on Desmos or whatever graphing calculator you would choose to use. All right, so pretty simple, no chi-squared. So y equals x 12 minus 2x and 8 minus 2x. The reason why it's 2x is you have 2 edges to it. And so you only really want to figure out the peak of, it's a third degree polynomial, but there's only one peak that you need to find. If I can get there. All right, so it looks like it's somewhere in there. There's my peak, so you just click on the peak. So if I make a cut of 1.6595 inches, so that's the square I've cut out of each of the corners, that would allow me to have a 67.60358 cubic inch box without a lid. That's pretty simple, I think, I hope. Questions on that? Number 2 says a time study that on average the productivity of a worker after T hours on a job can be modeled by that particular function. Don't really worry about the domain restrictions that they're given. I mean, they're making that is from a 0 to an 8-hour day. And where P at T is the number of unit produced per hour. After how many hours will the productivity be maximized? And what is the maximum productivity? So we're looking for, again, that kind of peak in this type of equation. We could just type this equation directly into Desmos and find it. Yes, you could go find the derivative and things like that, but I don't think you need to worry about it if Desmos is so readily available for you. So x squared minus x to the third. And so the reason why we're worried about from 0 to 8 is this does look like it falls into the negative region. So, gotta find the top. It's getting skinnier for a number of reasons. All right, so I think this region up here. So at 5.60555 hours into an 8-hour shift, the most production is being done at 163.74433 units. Straightforward enough? And then we start getting into where we have to start thinking if we can logically think. So on number 3, it says the owner of a retail lumber store wants to construct a fence to enclose an outdoor storage area adjacent to the store. And then find the dimensions to enclose the largest area if 400 feet of fencing material is used. Okay, so we're trying to make a rectangle based off this. So we have the store, and then we're trying to figure out how big this fenced in area should be. That's the storage area on the side. So if the store is 100 over here and this is X over here, that means down here has to be 100 plus X. We don't know what X is going to be. And then they give us a Y and a Y. Now that kind of messes a little bit with the dynamics of the problem. We have fencing is equal to 400 feet. So let's see if we can figure this out based on what's given to us. So I know right now that 2y plus x plus 100 plus x, all of these regions here is our fenced area. Notice I'm not including this portion of the fence because we're using the edge of the store to do that. Okay, so I think how you want to approach this problem a little bit is think about if you had this 400, basically you know that 400 minus 100 minus x would account for 2y. Okay, so let's pause there for a minute. How did I decipher that? Well, I knew the 400 was coming to us, and I knew that that was how much we had. We're taking away this 100 here, we're taking away this x here, we're taking this x away here, and then whatever's left over is going to give me 2y. So I could try and finagle this a little bit. So actually 400 minus 100 is 300. And then minus 2x. I can divide both sides by 2. So I'm going to get y equals the relationship of this. Okay, but is this really going to help me in this situation? And the answer is yes, because now I can actually take this, because that's what the relationship y is equal to, what we have left. And we can go 150 minus x and 150 minus x. And so if we wanted to figure out what the dimensions of the sides would be, I know that the perimeter of this, I have two 150 minus x's. I know that I have an x on top, and I have the 100 plus x on bottom. And so we can start just multiplying over, figuring things out. So that's going to give me 300 minus 2x. X plus x is plus 2x plus 100. And so that's going to give me p is equal to, the 2x's go away. 300 minus 100 is 200. And I think we now have enough information. Something's going on in some class. Not going to look. Not going to do it. What? What did you say? What's 400? Oh, yeah. Oh. So I think we just chased the dog around a tree a little bit. Yeah, 300 plus 100 is 400. All right. So that's not going to help us too much because we just chased the dog around a tree to get that back. All right, so, yeah. Well, hi. You're here to do the other portion, aren't you? Cool. All right. So let's figure out where we can go from there. So I know that right now I could say that x plus 20 times y is equal to 900. That's how I would find the area of the rectangle. Okay, which might or might not be helpful for us. But we also know that if this top is y, that means that I'm going to have, nope, I don't want to do that. I was going the wrong way with that. bet you we could do this. What did I just do to both sides? What did I do to get that 900 over x plus 20 from the area? Yeah, I just divided by x plus 20, right? All right, I think if I do this and I graph this, I'm going to look for what the x, where it crosses the x-axis. I think that's going to work for us. And if we do that, that should then allow us to figure out y, and we can solve the rest of it. 900 divided by x plus 20. Go home, find our graph. All right. Uh-oh. We're not going to get an asymptote. That's not going to work. Let's try it another way. Because that's not giving us where it crosses. Thoughts? Any help on that? Let's try one more time. Let's just put it down to the paper. That's x, that's 20, that's x plus 20, that's y, so that has to be y. And then we have an area of 900. Thoughts? Help me out. Things I know. Area is equal to length times width, which means right now all I know is I have this. What happened? Really?
Yeah.
All right. So I have a perimeter equation. So I have x plus x, which is 2x, 20 plus 20, which is 40, y plus y is 2y. So I have the perimeter equation, but then I know the area equation is that. So I think what I could do is, I think we were on the right path, we just didn't get there. I know this, which means I should be able to use substitution to come in here. Anyone see anything defaults that it's going to goof up with this? So that's, let's see what Desmos provides us on this, and it might give us some better thought for the answer. So I got 2x plus 40 plus 2 plus 40 plus 2 parentheses, oops, and 900 over x plus 20. It's going to be another one. All right. But I do have a local min at 10 comma 120. And I'm curious what that's going to give us. So 10 comma 120. So we're saying that this could be the answer. So let's see if that's going to help us. So that would mean if x is 10, this side would be 30. That would be 10 there. I know that's 120. And we want the area to be 900. So we're going to go 120 times 30. No? It's not 900. It's 3,600. I'm stuck. We have both what? I'm sorry. Oh, okay, I understand. No, I think you might be onto something. So you're saying for the perimeter where it's 2x plus 40, it should be 2x plus 20? Yeah, but I wouldn't be using that top 20, would I? Am I right thinking that? Is that what you're saying? Okay, so we'll say that'd be 20 for right now for the perimeter. So that would give me x plus x is 2x plus 20 plus the 2y's, which then that would mean that would have to be a 20 here, which then I think we're right with going y and x plus 20 to find the area. It's not going to work, so we change that to 20. It just brought it up a smidge, didn't it? 10 and 100. So 10 and 100 if we did it that way. So x is 30, 30, 10, 100, 100, and 100. And then that's still going to give us 3,000 for an area, right? All right, I'm gonna have to think about that one. It's a good thing I didn't give you one like that on the test. I don't know what I did wrong. I do have one thing I want to try though. Let's see. Where did I get that from? Oh, I see where I did my work. So when I worked it out, the problem, I thought that I looked at the 900 and I thought it was the perimeter that was given. I did not do it based on the area. So that goofed some stuff up. Okay, hang on. There's got to be a way to jump through this. So area equals y times x plus 20. And I know that that has to be 900. So that means that y is that. All right, I forgot what I've already worked out. So area is that. So if I said 900 times x plus 20 times, nope, that's not going to work. I was going to say, if I multiply it by this, that works, but those cancel. I got to think through this one. I got to figure that one out. All right. Then number 5 is going to be the same debacle because, again, I was looking at, oh my gosh, I got to learn how to read when I'm working these problems out. So I got to look up those two for you. I'm sorry. I'll get those figured out for you for tomorrow. All right. So I think we could take a look at the chapter 5 review. And let's see. 1, 2, 3, 4. I think you can hit 1 through 4. I'm just basing this on see on the test. And then 9 and 10. Thank you so much. All right, so give those a try. And I will figure out 4 and 5 for you tomorrow, but I'll make sure I have these right. I'll make sure I actually read the directions first